Right. I can't see any of you, but I trust that you're there, and hopefully you're here because you want to watch this talk on coroutines by me, Christina Lee. I am an Android engineer at Pinterest, which is about the only relevant life fact I have for you. And I just want to let you know that I really had great, grand aspirations for this talk when I submitted it of doing all examples, just all the examples everywhere. And then there's this thing that happened, which is that smarter people than I am pointed out the flaw in that. And this guy is dead, but people still seem to take him very seriously. And being empty or blind in my work didn't seem exactly like what I was going for. But fortunately, I'm a math major, so I know something about combinatorics, which means that while we ruled out only theory and only practice, and SF ruled out neither, there's still theory plus practice, which is great. So this is seems like the right track. And they didn't actually specify what that was. They were saying the thing about blind and about empty. Nobody actually said what this would get us. And so just to fact check, I went to Google because that's where you get all the answers. And it turns out that if you combine theory and practice, you alternatingly get a derivative form of chutes and ladders, a center puzzle piece with no external pieces, a giraffe being chased by a lion on stilts, or my favorite, an uprooted bonsai tree that's been graffitied by a bird. Now, all of these seemed vaguely positive, so I was pretty sure I was on the right track, which is why this is exactly what the talk is going to do. It's going to start with 5 facts that you need to know to understand the rest of the live coding that I'm going to do, and then it's going to go into live coding, and that live coding is on a sample app. I didn't want to give toy examples. I wanted to work in a real app using real data, and so it is going to be that. Now, I have a level of excitement right now that goes along with doing really dumb things, so let's all just pray that the live coding goes as planned, but this is what we're out here to do. So, probably should have better been called this, but anywho, we'll get started. Now, how many of y'all have used coroutines before? Okay, so a small smattering, but the majority haven't. So then I won't skip this section, but I'm going to go through it rather fast, which is the why of coroutines. And it starts like this. Threads are expensive. We know this because we have thread management, and specifically we have things like thread pools, where we don't want to create new threads. So we know that that's vaguely problematic. Coroutines are state machines, which means they have 3 key things. They have the data for each state, they have an index of the current state, and then they have the ability to wait patiently, which LOL, my mom is still trying to figure out how they got that and I didn't. But this is what they have. And it turns out that small objects are a lot easier to create than these entire thread environments, and so it's less expensive to do this. And what that means is that we're not getting rid of threads, but instead we're distributing these small objects across the threads in order to better utilize their capacity. This is a potato chip dispensary, in case you were wondering, and it's actually a really great analogy for coroutine dispatchers. But we'll get back to that later. Okay, so then there's this second part that JetBrains really likes to emphasize as well, which is function signatures, and it goes a little bit like this, which is if you ask for a model and you get back a model, that makes sense. If you ask for a model and you get back an observable, it's okay. And I love observables, they're great. They have a lot of stuff going for them, but they're their own unique person, and you need to get to know about them and their likes and their dislikes, and that can lead to a lot of this during that learning process. And so, if you have been using RX for a while, something like this might seem fairly reasonable, but if you have not been, something like this probably seems a lot more familiar right off the bat. And what this boils down to is that with coroutines, functions have the ability to stay the same, quote unquote, which is to say that you localize the change to a single point in time instead of passing a new type throughout. And all of this can be summarized by one less thing to learn, TM. Okay, so that's the 90-second primer. Now on to those 5 things that you need to know before we go into live coding. First, coroutines are a form of continuation passing. Now, there's a great talk on this that Ramon did at Kotlin Conf, so I'm not going to go into it. The only reason I want to point this out is because there's something that happens that goes like this. You write a suspending function called getModels, and what you get back is something that's getModels with a continuation. Specifically, there's the continuation, And oh look, it's being passed. Oh yeah. So why is this problematic? Well, because you find things like this, which is that when code expects a certain function signature, the fact that a continuation gets inserted can be problematic. Now, this is the synopsis, which is that it is a form of continuation passing. Why do you care? You need to be careful with libraries like Room that expect a certain signature. There's already a bug filed for this, so don't worry, but it's something to be aware of. That leads us to important thing number 2, which is that coroutine builders are bridges. Specifically, suspending and non-suspending code look remarkably alike. However, if you try to use them in the same way, they are not remarkably alike. Specifically, you get errors, and you get this error, saying that you could only use suspending functions from other suspending functions or from coroutines. Now, you can keep doing as many suspending functions as you want, but at some point you need to use the thing, and so that's where these coroutine builders come in. So if you're in synchronous city and you want to go to suspendable township, you would use a coroutine builder. That is how you get from one part of your code, the normal code, into your coroutine code. Now, there are several flavors of this. There's run blocking, there's launch, there's async. They're pretty self-descriptive. For instance, launch is something that's fire and forget. But these are given to you out of the box. And the main point to remember about them is that they are the entry point into your suspendable code. This is what we need to take away from this. And that leads us to important thing number 3 before we live code, which is that coroutine dispatchers direct traffic to threads. Now, hopefully this name makes sense. They're dispatching things to the appropriate location. And there's this definition of it, but I like to work with concrete things, and so instead of going through the definition, I'm just going to use this example, which if you used Rx before, hopefully this will look vaguely familiar. What it's doing is it has some repo, and it's fetching something from the network, and then it appends this subscribe on here. How would you do this in coroutine land? Well, it would look something like this. You have your coroutine builder, and you're telling it to operate in the common pool, and then here is your call. Now, common pool and subscribers.io are not the same thing, and so you can actually do something like this if you have coroutines Rx2, and what you're doing is you're taking the schedulers.io, you're adapting it with this extension function, and now you can use it again. So this might be more analogous. But the concept is the same, which is that you can still tell this thing where to begin its execution. Now, we don't usually stop with subscribe-ons. We usually also add these observe-ons. And of course, coroutines have you covered there as well. So specifically, what you get is you now have this with context block. So at the top, we're still launching with I/O. And then when we get that data back and we need to bind it to the UI, what we do is we say with context, and then we tell it to operate on the UI thread. Okay. There's one caveat here that I want to point out, which is that when you are in Rx land, you have this notion of upstream and downstream. So subscribe on affects things upstream, observe on affects things downstream until the next observe on, yada, yada, yada. In coroutine land, it's not like that. It's all based on blocks. So here we have this launch block. Everything in this block is going to happen on the I/O dispatcher, unless we specifically enter another block where we've specified something new. So inside the with context UI, that'll happen on the UI thread. Everywhere else, it'll happen on the I/O dispatcher. So this is vaguely different from RxJava, but hopefully still makes sense. Okay, there are a few that you get for free. These are built in, but you can also make your own, or as you saw earlier, you could adapt existing things to use with your coroutines. Now, there are some caveats about all of these different things, some knowledge that you need to acquire. Turns out threading is hard. I don't know who knew that already, but no, it's a thing. And so I'm not going to go into it because, again, this is focused on the practical, but there are plenty of blog posts that do go into this. Specifically, I really liked this one by Chris Baines, and I would recommend reading it. And we actually utilize some of the concepts here in the sample app. Okay. So out of all of that, what do I hope you walk away with? Well, basically, that subscribe on is to observe on as initial context is to with context. Now, I'm not sitting here and saying they're one-to-one, but they're analogous. If you've been paying attention, it's after lunch, so that's a big if, but if you have been, you might have noticed this word context popping up everywhere. And we were talking about dispatchers, and then everything started being context, and I didn't mention it, and that's a little sneaky of me. And so it's probably time that I actually explain what this is, and specifically why I can say with context dispatcher, because those don't seem like the same thing, except for they are, spoiler alert. So dispatchers are coroutine contexts, which leads to the question, what is a coroutine context? Important thing to know, 3.5, snuck this one in there for you. Coroutine contexts, they add context. I know that's a really silly definition, but it does exactly what you would expect, exactly what you're used to in activities and all of your other Android code, which is it adds relevant context. And so specifically, what can you do with coroutine context? You can pull out the name, which might be useful for debugging, or you can get the job, which might be useful for canceling it, or checking the children or its status. And if you're me, you can also create your own by giving it a key, some dubiously useful function, and then going to town. So this would, as expected, just print out the first 5 Fibonacci numbers, but if you were really ambitious, you could do something actually useful with this, like, say, pass an exception handler. So there are useful things to do, or you can do your Fibonacci generator. It's up to you. I'm not judging. So this leads us to our penultimate important thing to know before live coding, which is that you need to cancel things. So analogy time again. Disposables are basically akin to jobs. That's it. So if we go back to this example, which we were using earlier, we had this subscribe on, but I was being a really bad developer in practice. What I really should have done is something like this. And then eventually, I probably should have done something like this. Or if I'm being realistic, I probably would have had some sort of composite disposable that I used tied to a lifecycle method. Well, coroutines have you covered there, specifically in that when you launch one, you can get a job back. And once you have a job, you can cancel it. So you can also do a lot of other things with jobs that I'm not going to go into. But one thing to note is that you can also get the job from inside the coroutine context, which is actually pretty useful. So that's a fun little extra that you get in coroutine land. Now, most things are the same, but there are a few things that switch over. Like I was talking about composite disposables earlier. We don't have composite disposables in coroutine land, but we can make do with parent jobs and the like, which I'll go into in the coding section. But basically, things are pretty analogous. Where you had disposables, you now have jobs, they're cancelable, take care of them as you would. And that leads to our last item. So, coroutines are synchronous by default. This is somewhat of an unexpected statement, given that most of us associate coroutines with asynchronous work, but this is true nonetheless. And let's take a look at what that means. So this is how I represent code. I'm not sure why, but it is. And let's say that this is our normal code path, and we have this one job that's executing linearly. Then we have a coroutine builder. It starts this coroutine code. And the important thing to note is that both of these are proceeding linearly. We have 2 tasks. They are operating in a linear fashion. Specifically, what this coroutine code is not doing is something like this, where it has a bunch of different things happening in parallel, all while that normal code is executing linearly. Now, you can make this happen, but you have to opt into it, and you have to do it explicitly. By default, this will not work. It will not be in parallel unless you choose that. There's a very good reason for that, which is if you want to do a concurrency, I really hope you've signed the waiver and agreed that your code probably won't work, it's not going to be reproducible, and you're going to ask 10 people to look at it, and they're not going to have an idea either. So if you want to get into this situation, you really want to do it knowingly, which is where that requirement for being explicit and opt-in comes from. What does that look like in practice? Here is the smallest example I could give you. What does it do? It has a function that takes 10 seconds to complete. It has a function that takes 10 seconds and 5 seconds, and then I time the whole method. Predictably, because by default this is running linearly, you're going to see that the result of this is it finishes the entire 10-second task, and then it finishes the 5-second task, and the whole method took 10 plus 5 equals 15 seconds. So there it is. The 5-second task, wait for the 10-second task to be finished. Now, I can make this asynchronous if I so choose, but I have to be explicit, and I have to opt into it. Here, we do get that parallelization that you would expect. Specifically, you'll see that this 5-second task now prints first, because 5 seconds is much faster to complete than 10 seconds. And the total time of this method has now been reduced to 10 seconds, which is the time it took for the longest element to complete. Okay, so those were our 5 things. Basically, that continuation passing style is important when you work with libraries like Room. Coroutine builders are going to be the entry point to any function that we write that uses the suspend keyword. So every time I write that in the live code, bells should be going off. Dispatchers are how we're going to tell this where it should be running. Cancellation is going to work via jobs instead of composite disposables. And with synchronicity, every time I try to do something that I would like to be asynchronous or parallel, I'm going to use this keyword and I'm going to opt into it. All right, you have everything you need. It's time for the code. A little bit about the sample project I'm going to be working on. It looks something like this. Specifically, I'm hitting the Unsplash developers API. I'm pulling all of their trending photos. I'm putting them into a recycler view. And then I'm also adding a caching layer and some user interface where I can click things to change their state and persist them. So this is it. We have networking, we have different types of flowables and completables, and we have caching. With that, let's get to it and switch over here. So, of course, I did not leave off at the right spot because that would be way too professional of me. So here we go. I'm going to start with the networking calls and show you how to adapt those. And fortunately for me, there's some low-hanging fruit that I can begin with. Specifically, in here, I had this call adapter factory for Rx, and I can go ahead and switch that out to one for coroutines. This work has already been done for me. Thank you, Jake, as always. I don't know where he finds the time, but he does. And so now I can go into my service, and I can change this return type. So here I had a single, and now I want to return deferred. So great, that was the lowest hanging fruit we could possibly start with. We added our call adapter, we changed the return type. Now it's time to go look at the call site for this. Predictably, everything has broken because we're returning a different type. We used to have this Rx stream, now we don't. And so we can begin by destructuring this stream. First, we're going to add in our suspend keyword, and then we're going to take this line by line. So the very first thing it does is it calls the Unsplash service to get the curated photos. So I'm just going to say curated photos equals the Unsplash service dot get curated photos. And then I'm going to keep this logic exactly the same. The next thing it does is it subscribes. I'm going to pass over that right now because it'll happen somewhere else. And so then I'll move directly onto this flat map. Well, in coroutine land, we don't need to do this flat map. We can just call it immediately. So insert if not present and curated photos. Now this error here is saying that the types don't match up. And this goes back to that point about having to opt in to the asynchronicity. This is returning a deferred object. I need to actually ask it to wait for the real object, the list of photos, to be produced. Now you'll see that that type error has gone away because I have a list of photos here. I'm waiting for the network to complete before I do this next database call. All right, so that's the flat map code. And then, of course, we have something down here, which is the on next and the on error. We can do something similar if we want. I haven't really added a lot of code here, so mostly it's just 2 printlns. But if I want to add them, I can do something like this. And I don't know, maybe I want to look for errors of this nature. And then go in and move this. Again, the printlns aren't doing anything useful. I just want to show how you can use logic like this once you change the type. The same way that you would normally. So now, let's see. We took care of this Unsplash service. We did this next photo data source call. And then we took care of all of the subscriptions. Great. Now, the last thing we have here is this disposable. And I'm not going to deal with it right now, but I promise I'll get back to how you change this over. But for now, I'm just going to delete it. So there we have it. It's our first suspending function. We destructured that Rx stream one line at a time. But now comes the fun part, which is that we actually have to use our suspending function somewhere. So we can go ahead and jump to that call site. And ding, 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 we have a normal function and it's going to call something that's suspending. So the very first thing that comes to mind should be that we need a coroutine builder. So here, let's use launch, and once again, let's go through this and destructure it one line at a time. So first thing that's happening here is we're calling photo data source.getAllPhotos. This is coming from the DB, so I haven't yet converted it, but we'll go ahead and say updated photos equals photo data source.getAllPhotos. We'll leave that like that for now. And then it has this observe on main thread, so we'll go back here, and how do we do that? We'll call our with context, and we'll use dispatchers.main. Now, this dispatchers object is something I called out to in the blog post, which is just this object that I have injected via dependency injection, and this is an idea that Chris Baines had, which I actually kind of liked, but no magic is happening there. That's the only point. Nothing magical, it's just hiding away the instantiation. So, okay, we did our observe on, and now we get into this situation. So if we get these updated photos, what do we want to do? Well, this is what we want to do. We want to do this particular block here. Now, these errors are coming into play because, of course, the types don't match. This photo data source, it's returning a flowable, and what I'm looking for in updated photos is actually a list of photos. So I haven't converted this yet, but let me explicitly type it, and then leave this as to do, and we will return to it. Now, this is all yellow because it's unreachable code, but hopefully you'll see that isEmpty is no longer erroring because these types are checking out. So I have done the observe on, I've done the initial call, I've done the subscription. If you would like to handle the error, you can. I'm going to skip it for now. And then there's this disposable thing, which again, I will get to momentarily. So I'll just leave this to do up here on the updated photos, which we will convert in a second. And there we have it. We are using our suspending function from a normal function. Now, this was not the only place that called this fetch next photos. There's one down here, but luckily this one is easier. There's not much going on, so we can do something directly like so. And if you remember, if you have a very astute memory, I actually took out the subscribe on from the fetch next photos call, and so if I want to add that back, I can do something like dispatchers.io, because this is a network call. So now we have that subscribe on logic coming back here. The only thing we haven't really done yet is managed the disposables, or what used to be disposables. So we can go ahead and jump to that location. And this is what we used to have, this disposables object here. Let's get rid of it. And instead, let's create a composite job. Now, the reason this works is because jobs form a hierarchy. So if I pass one parent job, and later on I cancel that parent job, it'll get propagated down to all of the children. And so this is useful if you want to use it with life cycles, which is that you create this, you pass it as the parent to all of your coroutines, and then in the appropriate life cycle event, you cancel it, and it'll then go ahead and cancel all of the children associated with it. So let's go ahead and use this. We can get rid of this disposables.dispose and uncleared. We can use our composite job.cancel. And of course, it's not actually doing anything yet. Well, there's one other location where I have disposable, so let me get rid of that. It's not actually doing anything yet because I actually need to pass it here. And specifically, I'm going to say parent job equals this composite job. There's one other place that we've introduced a coroutine builder, so I'll go ahead and do it here too. Parent job equals composite job. And there we have it. We have completely converted this networking flow. What did we do? We updated our call adapter. We changed our service to return a deferred type. We then utilized that in a suspending function. And then when we needed to access that suspending function, we did it via launch, which is a coroutine builder. And we kept track of that work with our composite job that we could then cancel in a life cycle. All right, now we can move on to the database work. So let's just go take a look at what we're working with. And it's something like this. This is Room. I decided to use it because it seems pretty popular with all the cool kids these days. And it looks pretty simple. There's nothing ridiculous going on under the hood here. Specifically, these two things down here are completables. They're not really returning anything that I need. Here there's a long array, but that's just whether it was successful or not. I can take it or leave it. I'm very specifically ignoring the top flowable, and that's because that is going to be a different case that I'll return to. It's not quite as straightforward, because coroutines, they're very, very easy to adapt code that is a single, a maybe, or a completable. When we get into a flowable situation, it's not really its wheelhouse. Rx was made for these asynchronous event streams, whereas coroutines, this is a little bit of putting a square peg into a round hole. So we'll return to it. I'll show you how to do it. But for now, let's just focus on these two completables. Now, there's nothing really to do here, but we can jump to where they're being called, and we can see that there's a completable. Specifically, there are these completables and also the subscribe on schedulers. So let's go ahead and dive in. We can, again, say that it needs to be suspending. And then we know that this needs to be subscribed on the I/O, which is actually, I think, a typo. Let's do dispatchers.db, because this is DB work. And then we know that we need to do something asynchronous. So let's be explicit about it. Say async, do the work, insert all photos, and then wait for this to complete. Now, we don't need to return a completable anymore. If we really wanted to be accurate, like we would be returning a unit, but of course this is Kotlin, so we can leave that off. We don't really need it. We could do the same thing down here, which is remove this completable, because all we need is unit at this point. And then again, we have subscribe on, so let's do our with context, dispatchers.db. And then we need to do asynchronous work, so let's be explicit about that. Say photodow.update like status, pass it what it needs, and then wait for it to finish. All right, so, what did I do here? Oh, I didn't make it suspending, ha. Okay, so let me put with context back, and then update this, which is what I should have done first, which is to make it suspending. Great, we have 2 more suspending functions, and now we need to use them. And what are you thinking? Of course, coroutine builders, hooray! So let's go and use this. So everything's broken, as per usual with my code, and we're gonna fix it. So we know that this is a normal function. We would like it to call something that's suspending. So the first thing that we'll do is we will choose some coroutine builder, and then once again, we'll disassemble this Rx stream line by line. What is it doing? It's calling photo data source, so we'll go ahead and do the same thing. Persist like status, it's passing it these 2 parameters, and then when it's successful, it's printing this very fun emoji. When it fails, it's printing the fail whale. So once again, if we would like, we can do something like this. Let's put a placeholder exception in. Please don't do this in your code. But again, oops. This is just to show that you can indeed do stuff here, if you would so like. I am not actually, well, okay. This is not necessary, but you can, if you want to, do additional logic here. So what did I do? I already ported this. I ported the subscribe. If you recall, I deleted the disposable down here before, so I'm going to go ahead and add that back. And so where do we want this to run by default? Well, we can say DB. It's already being handled in the photo data source, but if we wanted to, we could do that here. They actually dedupe themselves. So if you start something on one context and then you say with context with the same dispatcher, it'll just check and then continue on. The overhead that you have is the one check, which when you're doing something asynchronous tends to be pretty small in comparison to whatever network call you're doing. But we can avoid it here for now since we already know that this is happening where we want it to happen. And instead, we'll just pass the parent's composite job. Okay, now you probably noticed that we updated 2 different functions. This one's a little bit of a cheat because it was already within a suspending function, so I actually don't need to adapt it at all because again, you can call suspending functions from within other suspending functions. So that's it. We've done these 2 database calls. We've adapted them, we've made them suspending, and then used a coroutine builder to access what they have to offer. So this is where we get to go back to our very fun streams example, the one that I was avoiding. Like I said, I'm going to show you how to do this without necessarily advocating for it because Rx and coroutines have very different specialties, and it's a little bit of an interesting case for me to try to force coroutines into this reactive space, but I've never had good judgment, so I'm going to do it anyways. So there's nothing for me to do here because Room can't directly return a receive channel yet, as far as I know. So instead, I'm going to go and work at this one level removed, which is what we were doing here was just basically getting this flowable and adding the subscribe on so nobody could accidentally subscribe on this in the main thread. Instead of that, I'm going to continue to get the photo.all, but I'm going to convert it over to a channel using open subscription. It's going to yell at me because, of course, the types are wrong, and that's because what open subscription returns is a receive channel. Now, this was probably something I should have discussed in the PowerPoint slides, but unfortunately I had limited time to do this presentation, and so the short of channels is basically that things can be offered to a channel and things can be removed from a channel. It's very much like a queue. And so what's going to happen now that I've done flowable.openSubscription is that every time that flowable would have fired, it's going to offer this item into the channel. And then me, on the other side of this channel, can start consuming them and saying, oh, I want to process that, I want to process that. So let's take a look at what that looks like. Oops, streams. So this is the to-do that we had from earlier. Now, we had this to do, and then before that, we had this call here. Again, the types are wrong. We actually know that it's not going to return a list of photos anymore. Specifically, we know that it's going to return a channel. So let's go ahead and type it as such. Get all photos. This is our channel. And now we're in this conundrum where we need to somewhere get these updated photos. We have a channel, but what we really care about is the things that are being pushed onto that channel, the emissions, which is this list of photos every time the DB gets updated. So what are we going to do? Well, we're going to use a for loop. What I can do here is I can say updated photos in channel, and then I can wrap this block of logic within this for loop, get rid of the excessive space, and now everything's working. Now that was probably a bit of magic, but this is a suspending function. So what this is doing is every time there's something on the channel, it's going to execute this block, and then it's going to suspend. And then the next time there's something in the channel, it'll pull it off, it'll execute this block, and it'll suspend. So this is going to continue to run this block of code every time something is offered to this channel. Now, I just noticed a typo, which is that when I was transcribing this literally from the RX stream, there's this with context, but fetch next page of photos should actually not be happening on dispatchers.main. It'd be pretty bad. So let's go ahead and change this over here, fix our spacing, and now when we get our data back, those updated photos, we're going to dispatch it to our UI on the main thread. And if we need to hit the network, we're going to dispatch that on I/O instead of blocking our main thread. So, yay, code quality. This should look a lot better. All right, there we've done it. We've done the networking. We've done the DB. The DB was slightly different, but it really followed the same playbook, which is that we marked something as suspending. We knew that it needed to be asynchronous, so we marked it as such, and then we waited for it to complete using await. We then used that via a coroutine builder, and we dispatched it to the correct location of operation using our dispatchers.io or main, etc. Now, in this app, I included one other example of dubious nature, just because I wanted to show you what it would look like to do something that's one-off. This is a adapter, the photo adapter, that's getting these photos and binding them to the UI. And I wanted to use diffutil somewhat just to make this case, but you know, it's something that's plausible in an Android app. And so for our last example, what I'm doing here is I'm creating this single. I'm moving the diffutil calculation off the main thread because sometimes it can actually be pretty expensive. And then when it comes back, I put it back on the main thread and update the UI. So what does something like this look like? Well, we already know we're going to need a suspending function, so we can start there. Private suspend, fun. I'm really bad at naming. We're just going to go with create diff. And then, once again, we're going to destructure our current RX code, starting with this chunk of work, which seems like the most important thing. So let's pull it down here. It looks like the two arguments that we need are the current data and the updated data. So let's do current data, and then this is going to be a list of photos. And then we can do our updated photos, list of photos. This should probably actually be updated data, just to make it consistent. And then we can change this over, so current data. All right, so that makes it pure. And now, what do we want to do with it? Well, we already know that we don't need this anymore. We know that we want to subscribe on, but we'll handle that later. Oh, here's an observe on. This is something that we can handle. So let's go down here, say with context. We'll say dispatchers.main. And then what do we want to do when we get into this? Well, we simply want to assign this to our local field, and then we want to dispatch it. So we'll go ahead and take that. We'll put it in here. Oops, updated data. And we'll dispatch it. And this is all happening on main. Okay, that leaves us with a little bit of cruft up here, but no fear. We have something that's suspending, so we know we need a coroutine builder, and this is going to be following much the same formula as everything else. So here, we know that we want to dispatch this. Let's see. What are we doing? It's a computation, so let's use dispatchers.computation. We know that we probably want to keep track of this, so let's give it a composite job, which I already cheated and defined, and then let's go ahead and call it create diff. The current data is going to be in the photo adapter.data. The updated data is going to be updated photos. And let's check all of our bases. So we have single.create, we got our subscribe on computations, we got our observe on main thread, and we did our disposable. And there it is. So now I've gotten rid of all of the calls to Rx in my app. If I want to be bold, actually, let's see. We have a minute left, so I can do this. Let's compile it. This is a terrible idea. Never do this. It's ever bad idea. And it's installing. Moment of truth. Is it gonna work? Oh, and it works. So you can't see this, but I can tell you. I can also lie. You can touch this. You can scroll. Things are happening. And if I had done this wrong, these would be crashing. So as you can see, we just successfully removed all of the instances of Rx from this app. We converted it over to coroutines. And the 5 things that were important to remember, once again, were basically that when you're using continuation passing style, you need to be careful with libraries that expect given function signatures. We use coroutine builders to access suspending functions from normal code. We have dispatchers in context to make sure that things execute where we want them to execute. We can cancel things using jobs. And of course, asynchronicity needs to be both explicit and opt-in. That's all I have for you today. I'll be around at the back if you have any questions, but I hope this was useful. Thank you.